Hi, so I'm going to talk a little bit about how size has an impact on the reactions and do a couple of demonstrations so that you can see that. Now, there's a fundamental principle of surface area to volume ratio involved in any reaction. That is, the smaller the particle, the higher that ratio is. If we can get more reactants into a reaction, along with the very high surface area to volume ratio, then we can get very dramatic results. It's why nanotech is so important, because nanomaterials have the biggest surface area to volume ratio you can imagine. So it becomes very, very important. Now, central to batteries is something called redox, which is reduction oxidation. Oxidation we recognize as burning. So if I burn something, like this candle, then we recognize it as burning, but it is an oxidation process, and we can see it, and that gives us an understanding of it. So here is an example of oxidation, and here's another one. This is something that you don't really recognize so much as burning. So there's a nice clean bit of steel there, and if I leave that steel out for a little bit, it'll do this, and it's no surprise what's happening here. This is rusting. And it's rusting really, really slowly. And we think of rusting, which is the addition of oxygen, incidentally, as being a slow process. Now, it's only a slow process because what we've got here is a massive lump of steel. And that steel has a very, very small surface area to volume ratio. But I can make it much more like this if I change that ratio. So what I've got here is a piece of steel wool. This is one of those that I don't recommend you do at home. So we've got a piece of steel wool, and all that is it's the same material here, but with a much, much bigger surface area to volume ratio. And I can actually make that oxidize in the way that you recognize as burning relatively easily just by touching a 9-volt battery to it. So if I touch a 9-volt battery to that, you'll recognize it almost immediately as burning. And there it goes. Now, it's quite slow because there's not much oxygen in there, but I can get it to go faster by adding more reactant. That is definitely not one to do at home. And all we're doing is making that particle smaller, increasing the surface area, and increasing the amount of reactants to it. And I can do something very similar if I use something like this. What I've got in here is iron powder, and I put the iron powder into this straw. And if I blow it through the flame, we get a very dramatic reaction. That's a bit tight. Nope, too tight. Let's try another one. There we go. And we can get dramatic reactions by improving those things. So taking that idea a little further with redox reactions and small particles, what we set up here is a thermite reaction. When it gets going, I don't want to be anywhere near it. So what I've done is I've put a chemical fuse in there, and we did that before in the fuses video. It gives me time to get it going and get well out of the way. That takes a little time to get going, but it is somewhat awesome. Oh my God! I was stood, and maybe, I don't know, 6 feet away. You could feel the blast of heat, and you can see it melted the steel pot it was in and created a pool of molten iron. That got up to about 2,500 degrees centigrade. So Those are the kind of things you can do when you pay attention to size.